All right. Good morning, friends. I hope I am audible to all of you. Anyone, please respond so that I can carry on.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, okay.
Yes, sir.
Yes, sir.
Thank you very much for overwhelming response. I'm more excited than you to deliver this contents and session because it's a new platform for us as we earlier discussed today. And I thank you all for joining, first of all, because joining a session is itself sometimes becomes challenge, and you have overcrossed this challenge. So I'm again thankful for all the participants, and I think 22 of them have joined. So before we go ahead, there is a requirement from our side that please enter your email, I mean enrollment number and name in the chat box, so that that would be my primary source of taking your attendance. So please do the needful, and please write your name and enrollment number in the chat box which is available over here, so that it will be easy for me to take your attendance before we proceed. And second thing, if anyone has any doubt or anything you want to discuss, I welcome your questions as usual. But the condition will be like I will be able to respond to your questions through your WhatsApp, right? So suppose I shall be going through your chat box. If you have questions, please put your question in brief in a chat box with your name, so that I will, at the end of the lecture, I will go through the chat box again, not only for attendance but also for your doubt solving, and then I will solve your doubt and respond to it, possibly today itself. If you have questions, I will put your answers in your WhatsApp group, so that you can get clarification on whatever you want to receive. So almost 28 students are now with us. So again, I'm repeating, those who are joining now, please do the needful to enter your name and enrollment number in the chat box. Okay, so with this brief, please have patience throughout the session so that we can comfortably discuss things together. All right, friends, this is a second time I think we are meeting today. First, we discussed a little bit about what is the speciality of this semester. So that I'll ignore introduction. And now straight away, let's begin the first technical session. My advice is to all of you that if possible, have a pen and scribbling writing tools like paper or something, so that along with the technical sessions, if you have doubt in between, you can mention your doubts, scribble your doubts in your notes, and later on you can put an entry in the chat box. That would be a good practice if you want, right? Okay. So we are together this time in the design of the concrete structures, or this time we are going to start design of the concrete structures together. However, it may reflect you with the different code over here, so that we have a common subject, so that I'm going to handle, so that we will carry on with the contents. So in today's session, let me give you a brief about Unit 1, and that is the building layout and design. So, friends, everybody wants to become, almost, I mean, wants to become a successful engineer as far as the structural design is concerned. So, for a structural engineer, as well as for the field engineer. This subject is very important because the layout holds a lot of importance in any of the structural system. So in today's session, I have dedicated this next few minutes on how to develop the insights on layout and what is its importance on the design. At the same time, I have also included couple of information that already almost all of you have learned so far. So friends, it's not like that you are learning this subject as a new subject. Let me tell you why. Let me give you the brief. Like, you have studied many analysis subjects, analysis techniques. You have learned the basic courses of mechanics, and you also have some exposure to the elementary design of the structure. So how to use this old knowledge, that is all about this new subject is. Definitely there will be a next step to the previous learning that you have done in your earlier contents. There will be a definitely advancement you will notice, but for this you have to expand your horizons. You need to recollect and rebrush your old knowledge to acquire grip on this subject. Friends, believe me, if you master these few subjects like mechanics of solids, like elementary design of structure, like analysis, and this subject itself, you will be definitely be able to design simple structures, ordinary structures very comfortably and confidently as well. Because in design, techniques, softwares, everything comes on a second row. The first row is your confidence and your understanding. So please be wise enough to relate old knowledge with the new subjects. Right? So in this package, we have two important terms with us. One is a layout, and second is the design. So how we are going to learn this together? By exploring what, why, and how. Now, how do we relate this? Now, what is a layout, that we'll understand? Why layout is important? And third, how to do a layout? That is a basic question, primary question, right? And similarly, we will also relate what is design, why design is necessary, and how to do a design. Now, this design is definitely going to be little higher side on compared to the old knowledge that you already have received, right? So this is our first interaction online. So I will be welcoming your other suggestions as well, if possible, as far as my technical presentation and details are concerned. So do not hesitate. As always, I'm always open to receive valued suggestions, good suggestions. So if you have one, you please share it in chat box. I will definitely look into it, right, to make the sessions more interesting. So we have learned following things in mechanics of solids. Let us say in semester 3, you studied lot many things about forces, force systems, CGMI, friction, and all this, and trusses as well. And then you went for semester 4 and 5, where you come across to SA1 and SA2 and concrete technology and other important subjects that you have studied. So in which you have explored what is SIKI, beam deflection, what are the column analogy, then what is ILD, how to use ILD in the analysis, and then you went for the most amazing building material on this universe for civil engineer is concrete, right? So we studied about cement concrete, their fresh and hardened properties. Then we went for mixed design, and special concretes also we have studied to an extent as an introduction. And finally you went for the slope deflection, the moment distribution method, the fixed beam analogy, the energy principles, ILDs, and finally you reached to the matrix methods. So friends, out of this list, if we refer to SA2, there are two important things I would like to highlight and which you need to recall and rebrush. First is the moment distribution method, why it is important, that we will discuss. And second is the matrix methods, right? So or the fixed beams, both. Because you know the fact of our structure made with concrete, right, is that the concrete structures are rigid structures, isn't it? Right? Everybody knows that. Concrete structures provides best rigidity as far as the workmanship is concerned. If it is very good, excellently done, you can have rigid structure in real situations. So fixed beam analysis is very important in that case, right? So the knowledge of the fixed beam, how to do the job, like calculation of the end reactions, end moments, reactions in vertical and horizontal direction, both will be, I mean all will be very important to us. So whenever you have time, by chance, if you have some material, please refer your fixed beam analysis component. But the topmost important thing is the moment distribution method, right? Now why moment distribution is there? Now you must be knowing, since you have worked with MDM, you know what we do exactly in MDM. We distribute the moments from one member to the another member due to the loading conditions on the beams, right? So how I'm going to utilize this old knowledge in the current knowledge in a way that whatever you have gained so far in terms of knowledge of MDM, we are directly going to use those calculation capacities to design the structure. Now, how do we do it? Like, you know how to place the UDL on the members and how to have a continuous member in that case, and how this UDL will generate end moments at the relevant connections. Now, once you have data with you, like moments available at a particular junction, you can definitely transfer the same to the next member by obtaining the relevant stiffnesses of the members. So based on the stiffness factor, I think now you can recall that you can distribute these values of moments with the corresponding members. Okay, so how much moment will be transferred on what basis, that will be highly dependent on the stiffness of the members. Right? So that I insist actually to you all for referring this old knowledge of MDM. Directly we are going to pick up this topic into the upcoming topic of layouting and design. Then finally you went for the last semester, where you get explored to the design of steel structure and RCC structures. We went for design philosophies. We have designed beams, columns, footings, slabs in a primary level. Similarly, in steel, we design connections and all this. So whatever you did in your previous semester as far as RCC design is concerned, it was just a hands-on practice, nothing beyond that. But now the time has come to integrate this knowledge of design into the upcoming uh, subject, where you are actually going to take the case study kind of things and you are going to design not only a component of the building, but actually you are going to design the whole structure at all. So it will be exciting also, because once you start designing the building, you have to start looking from the foundation itself. So from foundation you grow up to the slab level, so which comes and which includes actually most of the components of a building, like foundation, like column, below the ground, above the ground. Then you get mature to the beams, and then finally slabs and the frame, like. So all these stages you have to understand clearly, and I'm sure that you will be enjoying this subject like anything, because it is directly related to your real life situation. So it is a design, but not a simple design. It is a design of connections. It's a design of joints. It's design of the members, slabs together. Once you cast everything together, how the behavior of structure differs. That's what you have to understand, which is very important to understand. Okay. So all things we'll be discussing in the upcoming time. Then you probably have some exposure to the softwares, couple of softwares. If you have, by fortune, that's okay. If you don't have, don't worry. We are not going to use any software as far as this subject is concerned. Okay, so let's begin. Now, forces on a building due to gravity loads, wind and seismic forces. So this is our first content, and we will be referring following codes. These figures are not unknown to you, I suppose that the references are already there. IS 456, 875, 1893, all these codes at least once you have referred. Okay, so that we are going to refer again. Now, what are important points for us in this is gravity loads, second is the wind loads, and finally seismic loads. Right. So we shall be taking in the account all these things together for learning. Right. Uh, okay. Now let's move ahead. Well, if you see this circle and some associated punctuations, we can see that there are some cycle that you can observe on this slide, right? So what happens actually is it includes analysis, loads, effect, and design finally. But we will start from loads itself. So there are few of the loads which are important for us, which includes the vertical loads, self-weight, live load, then some horizontal loads like earthquake and wind forces. So all these are the primary and important forces. We are not expecting any extraordinary or very specified forces. We are simply dealing with self-weight, live load, and earthquake and wind forces. But even though if you deal with this, when you combine all the forces together, it gives you none, not less than 8 combinations, because we have 3 directions, right? And we have 2 plus 2, 4 forces. So nearly 8 to 12 combinations are definitely possible, right? So under this 8 to 12 load conditions, how will you design your structure? Because definitely you cannot satisfy all the requirements by each combination, isn't it? We cannot design structure for actually every case, but on the other hand we should always go for worst cases, the most dangerous situation where most of the critical things are included due to combination, that we have to design. Okay, so these things will elaborately discuss when the topic particularly starts. But let's understand what force effects are generated. So here you can see that effect or the actions developed by such forces in terms of load distribution to the members. First thing, first action takes place as distribution. So please focus on this word distribution. Now distribution can be in many terms, in many styles the distribution will get done. For example, you may have reactions, you may have internal moments, you may have the shear forces as well, and finally if conditions are like that, then you may have torsion also. So distribution of the forces within the member is the structural designer's primary focus. Always remember that. I hope I'm audible to you, because people are raising hands. So please stay tuned with me as far as possible, and please keep yourself mute so that I do not get distracted from your voice of your mics, right? So I appreciate your passionate learning in advance. Okay, right. Uh, Fine. So we'll go with the end reactions, shear forces, bending moments, everything we have explored. Now, when we come to the design, in RCC, we are concerned with steel bars embedded into the concrete, and we call it RCC, right? So why the steel bars are included, what is the exact role, that already you have explored, I know that. But here, the role of the steel members will, steel bars will be little different also. When you will be designing and dealing with the seismic resistant structure of the members, it will be having very important and different role as far as steel bars are concerned. So you have to focus that how you are going to deal with such details, right? And finally, you have studied some methods of analysis like elastic methods, plastic methods. Now here I would like to discuss in detail a little bit that what are the elastic methods. To be very frank with all of you friends, whatever techniques so far you have dealt with as empirical formula, all were called elastic method. Now what does it mean actually? The elastic method means it assumes that your structural material is elastic, which is completely wrong, right? So you may be in a dilemma, then why we studied it? So the answer is very simple. We assumed that the concrete or ideally the RCC behaves like an elastic material to an extent, isn't it? So we also went through the stress and strain curves, and we also discussed that yes, it is elastic up to certain limit called limit of proportionality or yield point, and then it becomes brittle, outstandingly brittle, and catastrophic failure takes place, right? So you don't have control on failure pattern of RCC materials or RCC members. You never know that in which pattern it will fail up to an extent, right? So what is the solution? If you want to control, see, the funny part of the learning of all the knowledge is a man wants to control everything. As a human we want to control everything, which is not a fact, right? But even though we have tried to simplify a couple of points through which we can at least not control, but we can at least have controlled failure, you know. So there is a difference. We cannot create the damage proof structures with RCC, definitely, right? But we can, on the other hand, definitely design structures which are in controlled failure pattern. Like you already know that if you increase certain type of load, this beam is going to fail in this way. So that is what is the expected outcome of this subject, that as a structural engineer of future you should know which are the best possible analysis methods available to you, right? So plastic methods probably we have explored in steel design, I think, if I'm not wrong. And if it's not dealt with, do not worry, it's not going to be the part of this syllabus, so don't worry. But probably in the upcoming semesters and in the master degree you'll get exposed to that. Anyways, calculation of sectional forces due to various loads, that is also you have studied. Like now don't be surprised that what are the sectional forces. Sectional forces are the bending moments offered by the member itself, the shear forces, and if possible the torsional effects. So all you have calculated. We used to cut the beam at a section, and then we used to calculate these two components, moments as well as shear forces. So all knowledge, in short, you have already. Now you have to arrange them in a way that it gives you complete notion or complete perspective on RCC design of the structure. All right. So let's go ahead in this. Here, I'd like to discuss again the cyclic process very quickly. It includes loads, forces, and when the load converts into force, when force converts into action, and when action is transferred to the members, how member responses, and finally the deformation takes place. And again, the load continues to get applied, and because of these actions, this entire circle is actually going on and on throughout the life cycle of a structure. So can you imagine that there is no end life for structure beyond this cyclic process. So what happens along with this is the action or the movement which takes place due to loads, which we call forces. So now you should have a notion, or now you should have clarity in your mind that what is a load and what is a force. So load is eternal. You cannot you cannot ignore it. It's like a self weight. You cannot be out of your self weight, right? So when loads comes into the actions, it's called forces, right? So we generally call dead load, but when dead load is applied, actually, it's working actually, it called force because it is creating some actions. And finally, when the actions are developed, these actions are compression, tension, bending, and shear and torsion. So all these are the actions due to the forces which generates in a normal regular structure, right? You know, the compression, tension, bending and all, right? So what happens when these actions are applied to the members, that we have to understand. So friends, when the actions are deposited, I will use this word because it is external, right? Generating externally. So when the actions are deposited on the member starts responding, right? So it is in a form of deflection. It's in form of vertical and horizontal forces and the deformations. It bends, it flexures, it cuts and get chopped due to the shear, then it gets twisting as well, and sway also. Now sway may be a new term to you, if I take it for granted that none of you know about it. Sway means it is a overall horizontal displacement of your rigid frame. So when the entire rigid frame, imagine a simple frame, the simplest form is two columns and one beam. So RCC column and RCC beam are connected, creates one frame, simple frame. And when you apply horizontal force, let it be a seismic force or wind force or impact force, the entire frame, the C-shaped frame, deflects in the direction of the force, which is known as this way, in a simple way, right? So this all are the basically nothing but the responses offered by the members. All right. So that you should have some background in your mind that due to the vertical forces, these many actions are actually going to happen with these members, and members will be responding according to their capacities, which we call moment resisting capacity, shear resisting capacity, and many more torsional capacities, right? All these things are included here. So that you need to keep in the mind when you are designing a structure. And finally, due to these responses, the poor chap, that is your structure, exhibits some deformations. Now, what are these deformations? Displacement, rotation, cracks, dislocation, sliding. Sliding is not directly related to the frame basically, but it's very, very important when you are dealing with the retaining structures, retaining walls, basically, and dams, right? So, sliding is something which reflects directly to the structures, but those structures are very spatial. So we are restricted up to displacement, rotation, cracks. So these three things we have to keep in mind when you are designing the structure. So let's go ahead and this slide explains the importance of the layout. So now we are focusing on layout. Till now we have studied some brief that what we studied and how to relate the knowledge together. Now layout is simply a word which is used to categorize structural drawings. Friends, repeatedly I have said in all the gatherings and classes, and every time I say that for civil engineers there are two languages. One that we speak by words, that may be your mother tongue, that may be your English or anything, and second language is the language of drawings, right? So even if you are not aware about the third person's basic uh, the language of communication. If you show your drawings, the third party or third person should be able to understand what you want to tell, on a ground. So indirectly, it is a communication, right, without voice. So that's why layout is very important for all the engineers. Let it be a layout of structure, layout of your building, layout of your walls, anything, any layout, that means a map, right? In a simple way, it is a map kind of drawing which includes many of the details. Now, which are these details that we have to explore today, right? So I'm going straight forward with this slide a little bit, like what is a layout? It's arrangement, orientation and connection of the skeletal members together. And sometimes it is very defined, that is called in a grid, and sometimes it's of a free form, right? Now, why this layout is necessary, that we are going to understand. To understand the load path, see, all have to focus on this. Load path is a very important key word for all of us, right? So, what do you mean by load path? It is the direction of the force which is transferred to the structural members. So, please understand this. Load path is very, very important for us. It will also guide you sometimes to design and to take care of the spatial junctions. So load path is very, very necessary to explore before you start designing. For example, you come to me as a designer and you ask me that, sir, I want to design a lamp post, right? So lamp post is the simplest structure, having some vertical, pipe and some horizontal arrangement to suspend your bulb or something, lights or something, right? It is a simple structure, but the stability is the prime importance. So strength is not the important criteria in this case, but the stability of your lamp post is primary important. So you have to draw rough load path, that if I apply some pressure, if I extend my cantilever part on the pipe kind of structure, how the load will get grounded. Similarly, there is a cyclonic effect, there is a tremendous wind pressure, there is a seismic activity taking place on the ground. In such situations, how your lamp post is going to be stable, that is your primary concern, right? So similarly, you have to see all the structures in nutshell format. Do not get into the complex analysis methods. It is a fixed cantilever and it is a non I mean, it's very complex structure. You have to use some softwares and this and that. Don't get into the complexity first. Whatever structure comes to you, you try to solve by first rule of mechanics, right? That what is my point of interest and what is the point of my load application, and it is my duty as a structural engineer that how would I direct and transfer that force which is taking place on a member to the foundation. That is what is my ultimate duty, because once your forces are grounded, up to 90% cases your structure is stable. But safely you have to do this job, right? And that's why we have to understand the load path. Okay, to ensure the stability and strength of the structure, one has to understand load path, and load path becomes clear if you have layout in your hand. So grid lines and member allocation are the inbite parts of the layout. Also, the layout says that means map, a map, right? A map will tell you that what is the orientation of the members and how they are connected. That is very important for us, because being an engineer, that what is the importance of connectivity. Connections means of transferring the forces from one member to another member. So if you don't support them, right, if you don't create the situation where the support conditions are nicely handled, it will be very difficult for us, to transfer the force from one member to another member. So friends, in this subject, not only, as I told you earlier in the beginning, that it's not going to only have important that how you will place the design steps and pass the subject. That's going to happen only. But at the same time, how you will become a unique structural designer, that depends on how you take this subject for your life path, for your career itself. So this subject holds a lot of importance, right? Okay. And third aspect is how to develop a layout. That is what the interesting part also, right? You will ask that, yes, we understand that layout has to be there. What is the role of layout? But tell us how to do it. So that's I'm going to teach you that how to develop the layout, right? By planning of a structural system, the first step to create a layout requires structural system understanding. On this, I will take 1 or 2 minutes more on this. Let us say we generally come across to a very typical word, load bearing structure, right? If you discuss this with your community or with contractors or with masons even, they will say that yes, this building is a load bearing structure. It is a sheerly non technical word, my friends. Load bearing means what? Everything which resists the force is load bearing, right? So I'm going to give you a new technical term, that is the non-framed and framed structure. So please onwards, whenever you discuss these things with your siblings, with your family members, those are in construction business, try to discuss with them that we have learned a new subject, the term today, that is framed and non-framed structure. So please start talking in a way that it gives you a kind of confidence. Now why I'm telling you this, because the ordinary structure, which has popularly a term known, I mean, load bearing structure, doesn't have frame structure at all. That means you don't have columns, you don't have beams together, connected together. Simply you have slab resting on a wall. All right. So that's why we call it load bearing structure. But actually, if you look into the details, all the members, all the structures are actually load bearing only, but whether they are framed or not, that is important. So onwards we'll be discussing this only, framed and non-framed structures. So you have to understand that whether my build, that doesn't mean that you should not construct non-framed structure. Please don't take it for granted. You can definitely construct non-framed structures with RCC slabs and walls up to 4 stories, not an issue, provided that you handle them carefully and apply the appropriate analysis and decide the appropriate dimensions. All right, so please be careful on that case. Next is, when you decide a structural system for the given building given to you, what next you have to see if you want to create a layout. That is what our main aim. Location of beams, columns, footings, walls and slabs. You have to check every detail available in a plan of a normal building. Let us say architectural plan. So you have to see and explore that how the beams are located roughly, how the columns are roughly located in case of frame structure. If it is a non-frame structure, you have to see that what are the boundaries for slabs, how the slabs are supported on the walls, and how the walls are transferring these forces or will transfer the forces to the foundation, right? So it gives you a kind of connectivity of above members, right? So that you have to understand. Frame structure, non-frame structure, there are no issues. Both you can design as a structural engineer. The only thing is people take it for granted that we can design non-frame structure. What's a big deal in that? The walls are erected properly and the reinforcement for slabs are laid down and you pour the concrete and your job is done. You forget about it. After 7 days, you will be able to have your building. That is a simple story people use around us. And once this negligence is used to construct the structures, we can see, we can notice the devastating effects during the earthquakes only. In normal days, you'll never find a problem, but when the shaking takes place, it becomes very tricky and very dangerous if it is not handled by a structural engineer. So even if it is a non-frame structure, insist your clients, your future employers, and all your colleagues that get it done by the qualified structural engineer. And this is why this subject gives you many important criteria being a futuristic structural engineer. Okay, and then you have to ensure the orientation of the members in planar area. You have to ensure that you have placed columns properly in a plane area. Now what is that? I will give you some example for this to understand in a better way. So before we do it, let's learn by a simple example how to finally this is a slide which explains how you create layout again in a different way. So I have created one phase wise learning steps, right? And finally when you come from the pale yellow to the bright orange color, you will be in a position to develop your layout, right? And I think I shall be giving you some reading materials as well as this PPT in your WhatsApp group, so that you don't need to copy or photograph anything. Don't worry, right now you just focus on what I speak and what you see in your screen. Everything will be shared with you, don't worry about it. I will be giving it to you, right? All right. So understand the function of building, that is the first step. Second is the identification of structural grids, that's what I discussed earlier. Then you have to locate and orient your columns considering short and long direction. Now third step is important, where my cursor is moving, right? Third step is important, like short and long direction means what? Of what? Short and long direction of load path, right? So you know that the nature is like that, it takes the shortest route always. This is a thumb rule, my friends, I'm giving you. Always think in a way that whatever is the structural system that you have provided will not be followed by nature. Nature has its own selection, and it will select the shortest route and path to get transferred from one member to the last member, considering from slab to the foundation. It will find its own way, and whatever comes in a way, if it you have provided member, it will follow that pattern. That is also a fact. But if it is not following that pattern, then it will result in cracking. Yes, so that's why you have to be very careful that you have studied the demand of the structural system by the building that you are going to design. It's very interesting exercise actually, and that is what we will do also in upcoming time. So then you have to locate, once you finalize the short and long directions of your plan, whether it is horizontal, it is vertical, or it is a square shaped or circular shaped plan, whatever symmetry is there, you have to explore those symmetries as well. Then you have to start locating and orienting beams, connecting members with the columns, because after all, columns are the legs of the body of the building. So if your legs are very strong, firmly standing, it will give you additional safety to the structure. Okay, so that you have to understand that you have to design column carefully as well and locate them carefully as well, right? Then decide the spanning directions of slabs and rework on column orientation if required. You may need to reorient it if required. Otherwise, cross check all the beams, those are connected at both ends. Sometimes it happens that due to the complex planning, complex location, complex designing exercises, it may happen that you forget to check that I have shown a beam in this plan, but it is not supported on both ends. So it creates a lot of chaotic conditions, right? So that is a very important step that you have to follow here. Next is check the beams connected with columns at both ends, consider them as a main beam in your structure, and then treat the beams not supported to the columns directly as the secondary beams, right? Then finally, confirm that all slabs are supported by the beams, including balconies and elevations. And finally, freeze everything as a final structural layout by your own. Right? You finalize everything and confirm once again that you have mentioned all the signages, you have confirmed that all the slabs are supported on a beam, you have confirmed that beams are connected with all the columns required, and then finally columns are properly located on the foundation properly. Okay, so that's how is the process of the layouting you have to execute, right? So friends, this I know in listening it's very simple, and in also it is taken for granted many a times that all students says that okay, okay, we got the point, now what's next? So next is we want to have hands-on experience on this work. We want to do an exercise, small exercise, by taking an example. So learning by an example is always beneficial, right? So let me uh, take you to the next step of learning. Please look at to this plan. It's very simple plan, as you can see. Contains some three main rooms. One is veranda, front veranda, and second is some other room, right? So this is a very simple primary plan. Now I want you to place uh, the columns in this, because we are going to construct this as a frame structure, right? So in a frame structure, suppose this is a first step that right now we have discussed. I will see that yes, it is a normal structure, G plus 2 or G plus 1 structure at the most. So I'm going to go for the frame structure, let us say, because our ultimate aim is to understand frame structure. So I want to develop my frame structure in this plan. So first of all, I will see that what are the corners, where are the corners. So as you can see, and where are the members meeting at a point. So practically speaking, at everything, every corner you have a connection. So as a thumb rule, what I will do, I will place columns at all the connections, so it will look like this, right? Something like this. So what I have done in this, I have placed columns, assuming that all these are going to be my beams. You can see my cursor moving in, and I can see that all the members are like beams, and I have placed columns everywhere. Wherever I spot the connection, like here, yeah, here, everywhere, I placed it as a column, right? So should I take it for granted that my job is done, my layout is ready? Can I tell you to the client or the engineer that as a structural engineer I have done my job, I have placed all the columns at important spots? So somebody will laugh at you that it's not a complete exercise. Why it is not complete exercise? So here I'm going to give you the second thumb rule for your lifetime being a structural engineer. Consider the term called structural efficiency. I repeat, structural efficiency in your building system. This is a very important term which is going to affect not only your economy, but also it's going to affect your unnecessary expenses on the building construction site, as well as it's not going to be proved as environment friendly as well. So efficiency is very important at every stand, every time, which you have to go through, right? So you must have a question now that then what is the efficiency? How do we achieve efficiency? And what is wrong in this actually? Right now, if you said only that all the beams should be supported with two ends together on a column, so that's what you did. So what's wrong in this, right? So quickly, before we complete today's session, let's discuss this point. uh, yes, I have spotted three things here. There are three red dots. Those are the columns again. But what if I remove them? If I remove them, will my structure be compromised? Definitely not. Why? Because when we say that your beam has to be supported by two ends, there is no condition that it will be always supported on columns at both ends, always, which is next to impossible also. Sometimes it is followed, sometimes may not. So here you can see that I have a beam here and I'm supporting it with the another beam. So my beam is resting on the other beam. But ultimately my intention is clear that I want to support this beam, and I have supported it with the help of another beam. That is another story. I removed this column from here. You can see this red spot here. I have removed it. So no issues at all, because I have already two strong legs over here on which I can support my basic beam, right? And on that beam there is another beam which is resting. So since I'm working with RCC, joining a beam is not a big deal. I can pour a concrete, I can rest my reinforcements like that, and I can execute my frame. All right. So this is how you should think about to utilize the best available options in the given structural system. So again, I have, please check it to the cursor. I have removed this column as a red spot in this, and you can see that this column and column, actually I could have give numbering to the columns so that we can discuss in a better way. I'll do that in next class. Okay. So in two columns, you have supported another beam over here. Now this beam, you can think about it that it is a rectangle, so major load direction will be in horizontal direction, so maximum load will be coming over here, and there will be at least 1/4 of this total area load will be acting on this beam from this side, upper side, and from lower side almost 1/4 of the force will be acting on this member again. So indirectly we can say that up to 3% of the loading will be on this member, and this member is supported on another member. But I'm ensured that this member is supported on another columns, so in a way my structure is stable and safe. So I have grounded all the forces. If you check now this plan, whatever forces are there, I have grounded. Forces means how you ensure, supposing there is a wall all over the beams, so all beams are connected at least on two sides. This beam is also connected here on the another beam, this beam is connected on this beam again, and finally this beam is connected here. So ultimately I have connected everything together. My load path is now very clear, right? And that's why I'm more than confident that I will be able to transfer forces effectively. So friends, this drawing which is in front of you, however it's not a complete drawing, it's not an engineering drawing, but it reflects somehow, to an extent it is an example of layout. So for us now onwards, whenever we discuss layout, you should think about this sketch, that there will be some columns, there will be some beams, there will be some slabs also, and there will be some notations and other legends, other symbols also, right? So with this, I think whatever I wanted to give you today as a notion, as a point of start thinking about it, this was something basic I want to discuss with you today. So with this, I will stop here. I will end here my session right now, but you have to start thinking. Don't stop thinking here. Actually, you have to start thinking, right? And I have utilized this presentation, which was common for the other sessions also, but you will have your dedicated material with you, which I'm going to share with you. Don't worry. So on a same topic. So what I want to discuss here again, please start referring your old knowledge on MDM, old knowledge of mechanics of solids, as well as some knowledge of your RCC design. You are not supposed to deal with steel design right now. Probably that will be included in your next sem. But here, this time, you have to restrict yourself with RCC design. So please start referring old IS codes, start referring your reference textbooks and other things, right? And start to connect yourself with the subject again. Okay, I have spoken enough from my side, and I can see 46 messages in the chat box. So I appreciate, and I will be going through this chat uh, later on probably. I have received almost all the numbers with me. Here I can see that. So that's a good sign. I will definitely punctually note down all the numbers here for my attendance purpose. Please start reading, relating your thing with the contents. So I'm stopping here. If you have questions, by the way, I give you 1 minute in case if you want to discuss something, please put it in to the chat box. Else, we are done from my side, and I'll stop the session here. Please connect yourself with the subject again. So thank you very much for passionate learning, and silently you followed my instructions. So I'm grateful to you. Uh, Keep learning all the sessions by other teachers also. Okay, so we'll meet again in our scheduled timing with some interesting component from this point. So now onwards, I will not discuss these basic points. Directly, I will lead you to the next stage of learning of layouts, right? Okay, so well, thank you very much. Anything, if any point is there, even still you can discuss in your WhatsApp chat also, or tell to your coordinator that he or she will discuss with me again. All right, so take care. Meanwhile, be very courteous and be very hygienic in your personal habits for the COVID situations. Do not roam around. Let it be lockdown is lifted up now, but you have to be extra careful when such situations are there. Okay, so safety first. Your life is very invaluable. Everybody's has to be taken care for this situation. All right, so with this wishes, I'll sign off this session. Thank you once again.